look into a actual case study wherein we have successfully done a continuous testing along with cloud testing implementation, which is Source Lab, for one of the leading online assessment solution provider. So as you see from here, it has got a wide fragmentation to be tested, multiple browsers from both the Windows and the iOS systems, and also it has got to work in a responsive design in terms of mobiles and tablets from both the Android and iOS platforms. So the manual testing or kind of conventional testing, legacy testing was the one which was existing initially, and it was really impractical to cope up with the time to market, and the testing cycles were getting extended, and it was really consuming like around 40-50 days of manual effort if we have to test rigorous everything and then push a set of code to the release in the production. So here came the solution of continuous testing and further integration with Source Lab Cloud to cover the entire fragmentation of devices you see here. And these talking about the CI practices which we deployed here, as you see here, it's like we just bifurcated and then segregated the actual certification scope into 3 layers, which is like smoke, regression, and integration. So the smoke is a kind of a prime deciding factor or a kind of primer suite which actually decides whether the code which has got checked in is stable enough for the next level of deployment. So it's like 15 minutes, just a quick test which lasts in different platforms of 7 browsers and 7 devices in parallel. So any showstoppers we see here, we abort the execution, trigger an email, notify the respective audience who have to action on it, and then we just cut off the code movement to the next level in the pipeline. In case if it is true, then it moves seamless to the next level, the code gets promoted. Also, we just trigger the next set of scripts, which is called the regression suite, which does a deep dive in terms of testing. So as you see here, it again goes through 7 browsers in parallel, runs for around 8 hours, triggering parallel test in Source Lab Cloud. And once this is true, it gives us a next level of confidence, and then the code moves to the next level, and then we further run the integration suite. So it goes in a cyclic manner wherein for each and every build, we we just segregate everything into kind of smoke, regression, and integration. So integration has got to do more with a kind of end-to-end test. So whenever modules are tested standalone and certified, here is a chance wherein we interlink all the modules and run them in one go so that the real-time business scenarios actually get tested here. And talking about the technical architecture, how this continuous testing was implemented with Source Lab Cloud, is he started with the Aspire framework for test automation, which is AFTA, was integrated and residing in a kind of big bucket repository. And this repository was linked with Source Lab Cloud, and through a continuous integration listener like Jenkins, the Source on-demand plugin on WebDriver test matrix, we were able to configure the same set of automated test scripts across multiple browsers and then mobile devices. So which really made it a kind of flexible, reusable piece of code getting executed across multiple platforms in the Source Lab Cloud. And then through Source Connect, we were just able to run it in the Source Lab Cloud, trigger the scripts in Source Lab Cloud. And for the Source Lab had a kind of report publisher, so it gave us a kind of audit trail of whatever has happened during the real-time test execution. And also it captured videos of each and every test run during the runtime. And talking about the continuous integration workflow, how this build unit test, just one cut phase actually got promoted to the real production environment is the complete DevOps cycle you see here. Like people code and then they keep on pushing code in the development environment, and then it goes to a kind of version control, gets deployed and then a set of tests get triggered first. Once the test results are passed, then it gets promoted to the next level. So it's the first level is a kind of the quality gate check 1, wherein the build and unit test are verified, then the code is promoted to the QA environment, wherein we run the real-time full regression suite. So once the tests are passed, then the feed gets committed, and then the next level comes into picture, which is the UAT test environment, wherein the next set of scripts lined up here gets promoted. In case if there is a failure, then there is a push or a kind of fallback mechanism wherein the further stages of code promotions are arrested, and then the respective team gets to understand the logs, the technical failures from the logs, which is part of the framework, and as well as they take a look into the live demo, which is captured in the Source Lab cloud, and then whatever is the corrective action required, the team start working on it very quickly. So it's a kind of unattended execution which gets automatically triggered through this kind of integration mechanism, so that any kind of code check-in whenever happens, the testing process gets started automatically, and also the results are notified automatically from this kind of an integrated setup. And once all the 3 quality gateways are through, it is then finally the code gets qualified for a production deployment. So here is where we just get to see the complete vision of the test coverage, which was literally achieved using this continuous testing and Source Lab integration. So Smoke, which had a widespread of 7 desktop and 7 devices, and then which was consuming around 12 hours before automation, we were just able to reduce it in 15 minutes through multiple threads, through parallel executions. And also the same is the case with regression and integration. So 100, 80, 90, the percentage figures you see here is in terms of the test coverage. Certain test cases, they were parked outside automation because of some technical restrictions that we were not able to execute it in one go. Probably it needed a batch intervention, it needed a wait time. But the rest of it, we were just able to automate in no time, and the execution really helped us a lot when on-demand builds were happening every day with multiple teams keep adding up in the development end of it. This rigorous continuous integrated automation code integrated Source Lab was giving the prime confidence for code promotion to the production. And from the technology standpoint, the application was a web application with responsive design and designed with REST APIs, and had to support with multiple Windows and mobile, tablet, iOS and Android platforms. And from the solutioning, test automation, continuous testing point of view, the solution primarily used here was Selenium WebDriver with Java scripting, and then with continuous integration using Jenkins, and cloud execution facilitated through Source Labs, which enabled cross-platform execution, cross-browser, multi-device execution, and headless testing with REST APIs. Even this calls were integrated with the GUI layers, so that while we were running the integrated test, there was a clear functional sync of the output delivered by the API calls, whether it's being picked up and whether it's being displayed in terms of the GUI layer as such. So this was a complete end-to-end test, and the ROI we realized out of this particular project. And while we get into the finer details of what was the turnaround time in terms of Smoke, regression and integration, whatever was happening for us to give for before pre and post automation, it was literally like less than 1/10 of the time. And also we were not planning explicitly to run the test automation. The environment was all set, so it is on demand, and whenever there is a code check-in, the process was pretty automatic. And with the team size of 12, we did not get into a greater mission of team expansion or anything to support newer functionalities. So with the same size, we were able to support, which is like the complete QA focus moved on into parallel streams of new functionality testing, and then also parallel automation and regression, integration, supporting the continuous testing, and then continuous delivery in a DevOps mission. So this was just accomplished with an optimal team size by just bringing in this integrated solution of Aspire framework for test automation integrated with Source Lab cloud. And the savings in terms of numbers is what you see in the tabular columns below. So whatever we had, like in terms of the duration, the initial development effort was something which we took to set up the framework and just bring in the solution, cement it, and then after that it became a complete reusable piece of code with a minimal maintenance effort. So this accomplishment, it stands out like, and it actually replaces the need for 100 physical VMs, which are actually required to run all these set of test cases and certify them for any code promotion or a kind of in terms of the release management. And also talking in terms of the numbers, I mean the cost involved with the procuring an infra, maintaining it and scaling it up or down, because there will be kind of major releases, minor releases and kind of patch deployments, depending on which the number of fragments that we test also varies. So having a kind of a cloud infra like Source Lab, which will really help us to scale up or down based on the number of platforms that really needs to be tested. So this is a kind of diversified testing requirements that we were able to accomplish by this kind of integration.